Now, on the S4 sponsor stage is the session from Claroty.
All right, well, let's just jump into this. So I'm Patrick McBride. I'm the Chief Marketing Officer at Claroty, and I'm joined with a couple team members here, most notably Benny Parat, who is our CTO and co-founder, who will keep me out of trouble with any really hard questions. But welcome to Miami. Hope you're enjoying S4 and sunny Miami. Hope you got here a day early and got a little fun in or stay a little bit longer. We've been here since last week, so it's no hazard pay here. We were here for our sales kickoff. It was a good way to line up a couple of things. So today we want to talk a little bit about extreme visibility, but not by itself. We're going to talk about some cool new features that we've introduced into the product, but we're going to talk about these features from the perspective of how they can drive reduce cost and improve risk reduction over time. So we didn't just do them to be interesting and cool, we did them for a specific purpose. And that's really founded on a number of implementations that we've done. And a lot of our implementations really skew large. We've got very large enterprises that we're dealing with over multiple different industries. So what we're going to do in the presentation, I'll take you through the quick overview of Claroty. We'll move on. Most people know who we are that have been involved in OT security, so we'll move on from that pretty rapidly and jump into some of the new features and go through some scenarios. So we exited stealth mode in September of 2016. It seems frankly much longer than that. We've been running pretty hard ever since. We've rocketed to the top really of the category pretty quickly. That has really all the credit to do to our R&D and engineering teams. They've just built a great product. We've been able to do that, and we've been able to fund a pretty comprehensive product because we're the best funded company in the space. And more importantly than just having a big check is who gave it to you. And so we've got quite a bit of market validation. So some of our investors include some of the major automation vendors who you can see on the slide there. Rockwell, Siemens, Schneider all tested and validated our technology and then decided afterwards, actually, quite a bit later to invest in the company based on that. So that's important. But the more interesting piece of that is some of the largest asset owners around. You've got people like BMW or Temasek, who owns a huge number of assets in Singapore and beyond, or Tekfen in Turkey and others. So we've got really an interesting conglomerate of folks that have put their faith in the company over time. So pretty cool. And we build really a global operation with those funds, and we continue to scale that. We're operating in lots of different countries now. I think 10 countries we've actually got a footprint in, and people all over the place, with major sites in obviously in Tel Aviv and New York City, Houston, et cetera, in the States. So I wanted to just spend a quick second on some of the overall platform capabilities that we had. We decided right from the beginning to build out a comprehensive platform. We didn't want to build a one-trick, one product pony, kind of thing, point product. We set out right from the beginning, and that's one of the reasons that we funded the company and put the kind of capital behind it that we needed. So what we're going to spend most of our time to is on this first two, advanced threat detection and continuous vulnerability monitoring. But we built out a platform that lets you to provide proactive controls in the environment, do control access to the environment, and then do a good job of detecting both vulnerabilities and threats in the environment and responding to those. So really tried to put together the full kit. Certainly not the end-all and be-all in anything OT cybersecurity, but we really tried to do a big footprint because all the CISOs that we talked about said the last thing they wake up in the morning thinking is, let me get some new technology that I need to integrate. They really wanted a more comprehensive solution that could cover as much ground as possible. So let's talk a little bit about what we've recently introduced, and we call it multispectral data acquisition. Some of my guys give us it's really a holder name, and it means that we've got multiple different ways to collect data. A lot of folks may be surprised by this. A lot of folks kind of know us as the passive DPI-based company, and that's certainly something that we do and we're very proud of and we'll talk to. But we've introduced, in order to give really a complete picture of the OT environment and also address some cost and configuration issues, we've addressed a couple of other techniques. So we've added active to the kit. I guess the real way to say that to be most accurate would be we finally GA'd our active capability. We've actually had it in production for over 2 years at a couple large refineries. So this is something that we were slow and steady, waiting both for market adoption and really perfecting it ourselves before we felt comfortable doing that. And we've added something that we call AppDB. So active, passive is standard, sit on the span port, watch the traffic as it goes by, analyze the traffic. Active is query-based, not agent-based, but queries into the environment, whether we're talking WMI to the Windows machines, SNMP, or we're talking about specific protocol, OT-based protocols, discussions with a controller to get information out. So we do, active for us is a really broad stream of things. AppDB is an innovation that we had really pushed by a couple of different customers who wanted us to do this to give high 90% visibility into their environment, and we've with that capability or this combined capability, that's what we're getting now. We're getting very, very high levels of visibility in the environment. Way past the POCs that we've been doing with other customers. That's a means to an end, and we'll talk about the end in just a second. But with AppDB, what we do is we can parse the configuration files that the control automation systems provide when you do a configuration change to a controller. That's used not everywhere in environment. It's certainly used in critical infrastructures, making those backup files. And some of those files are created by the actual automation vendor. Some of them are third-party applications you can plug in to get backups of the controllers and things like that. So being able to parse that, understand them, and they're not just, we're not talking CVEs or CSV files or things like that. We're talking about most of them are binaries, so you have to reverse these and really understand them in depth. But what that's really given us is the ability to understand near 100% visibility in the environment. So why did we do each of these kind of quickly? Passive, we went after that first because it was the safest option, and attackers can't hide from it. If you're going to do something that is going to cause an impact to an OT environment, take down the process, injure somebody, break a piece of equipment, et cetera, have any kind of impact, you can't hide across the network. If you can see what's going on in the network, you can see them, because at some point, even if they come in on a thumb drive, they're going to have a footprint there. We can detect early and late in the kill chain. It's near real time. It's not rocket control, rocket based system, but it's a near real time database. I heard a comment earlier today that it was somehow slow, which is definitely a falsehood. And we can detect 0 days, and I'll talk a little bit more about that as we go along. Active, the reason we went, because it wasn't limited to the data that was traversing the network. So we can go get richer configuration information from controllers. We can get rich information, for example, from the Windows workstations. You can get things like the patch level, revision levels. So we might be able to identify it's a Windows workstation, know that it's running a certain vendor's automation software, et cetera, but you might not know all the packages on it or all the rev levels. So that's a piece of it. So getting the detailed configuration data was important, and especially if you don't have a managed switch. If you had a chance, and hopefully if some of you did have a chance this morning to listen to Nick Charnley's talk about operationalizing this kind of technology, selecting the right vendor and operationalizing that, there's a whole lot of nuggets in there that are all true about some of the things you needed to have in place. If you're going to do passive, you have to have span ability on your switches, for example. With active, you don't have to have that. And again, we waited till the market was really ready to accept that. So our AppDB is actually the safest of these. It's fully offline. Basically, we're waiting for a file to show up in a directory. When it does, we read it, parse it, and add that information to our asset database. And all these things can work hand in hand. So these aren't mutually exclusive. They can work. If we get some of the information with passive, we can augment that with active or AppDB, et cetera. You can get the detailed configuration data much like you can in active, and it's super cost effective. I mean, you can do this even if you don't have kind of the network and switching infrastructure. You don't have to bolster your network at all to do this kind of to put extra traffic on it like you might have to do with active, et cetera. So the combination of these things are interested, but we're not trying to give you a full picture because it's cool for us. We're really trying to give you a full picture of it so that we can streamline your vulnerability and patch management process, so that you can do much better threat detection and, importantly, triage and response. And you can do all of that with reduced operational costs. So that's what I want to spend the next piece of the talk, the second half of the talk, going through. And we broke out kind of two scenarios. First, we're going to talk a little bit about OT vulnerability and patch management, some of the issues that we see. in large organizations. And again, we're talking about, I think our largest customers on their way to implementing 100 sites. We've got multiple sites with 50. So these are, and these are large, globally distributed organizations. So if you're going to do these kinds of deployments, this has to be top of mind. You have to, really understand how you can optimize this in an operational mode. So we'll hit the OT vulnerability and patch, and then move on and talk about a threat detection scenario. So if we look at patching, there's already headwinds, right, in patching in OT systems. There's things like making sure, that the vendor, that the OEM vendor will actually let you apply a patch, for example, make sure that they validate it. It's not going to invalidate your warranty, making sure that you've got downtime to be able to actually apply the patches and such. So we're already fighting headwinds in that. The last thing you really want to be doing is chasing your tail around, finding or figuring out if your system is actually vulnerable when your tool told you it was. And we're seeing a lot of that. We see a whole lot of false positives, really not very good matching between a known vulnerability and the actual device. There's two really root causes of that we had to solve when we took this into mind. And it's important, right? You don't want to waste time, running around. It both costs you money, and it defocuses a team so they're not focusing on the vulnerabilities that actually count. Now, first was that a lot of the tools weren't able to get enough detail about the assets so that you could have things like model number and firmware version, et cetera. So that was one of the problems. The other one was, frankly, the CVE databases, the open source CVE databases, whether it's NDB or from the vendors, or we're talking about the ICS CERT database. A lot of those they're great. It's got a lot of information in it, but it's missing a bunch of information, or some of the fields that you would want to do matching on are in text fields, and so there's a lot of massaging of that data that you have to do in order to really get this precise matching. So those were the two issues. The other issue was, frankly, just assets that weren't visible to the tool, so you never knew you had a vulnerability that you had because the tool never saw the asset. Particularly, we see that with nested devices, where you've got a network card and a PLC, and you've got a set of under devices, either multiple network cards that you need to look at, or a whole other network that you actually don't have visibility into, serial networks, et cetera, underneath of that. So those were the two main issues that we set out to solve. So as you can see from this example, we've kind of taken one of our screens and cut off the top. That this happens to be a Rockwell controller. There's a bunch of information above this if you scroll up about the controller and what it does and all that stuff. That's all stuff that we automatically gather, of course. And then you can see the set of CVEs that we match, and we know that these are exact matches on the CVE. This is we're on our full match tab here, and the reason we know is that they're exact, or the reason we can make this exact match is we can understand, for example, this PLC happens to be a card and slot architecture. So you've got multiple cards in the PLC. Each of those cards has its own model number and its own firmware revision number, for example. So instead of saying that this device may be vulnerable to some CVE, based on the fact that it's a particular Rockwell controller, you want to know exactly is that particular firmware release vulnerable to that or not. So that's what we're talking about, exact matching, and you need this level of depth in order to do that and not chase your tail. We do that we have a Rockwell example. This happens to be a Schneider example. We've really done this for all the families of controllers that we support passively. If you want to see that list, it's a really long list. It's right on our homepage. You can download the PDF that talks about all of our support for the protocols that we've done so far. So kind of summary-wise, if you miss vulnerabilities because you don't see certain assets in the network, that's bad for risk reduction, right? If you get a bunch of false positives because you can't do this really precise matching, and that's what we're seeing when we go into POCs or see other tools in place, you're just getting a big ton of vulnerabilities, a bunch of them which actually don't apply to the equipment that you've got installed or the versions of the equipment you've got installed in your environment. So I summarize what we needed to do to solve that problem. Provide complete visibility so you're not missing some of the vulnerabilities on assets that you can't see on serial networks and those types of things. Provide really deep visibility into the components. Have a CVE database that you can actually do automated machine matching on, has all the complete data for all the versions and things like that. And then with all that, you get to plug and play that into your existing vulnerability and patch management process. So that's really how you kind of optimize and how rich data supports that. So taking the next step, we'll talk a little bit about our threat detection scenario. And there was 3 problems that we wanted to highlight here that we see fairly routinely when we're at client shops. The first is just detection. You got to be able to detect a range of threats. Known threats that you might have signatures for, et cetera, and unknown threats. Example of a 0-day kind of thing, something like Triton that, the back end of Triton, at least the payload part of that was trying to attack the safety system and bring it down, was a 0-day. It was an unknown threat prior. There was no signatures for it. So that's an important piece of it. The other problem that many organizations are facing is just SOC teams that are really overloaded. There's all kinds of models out there. Some are OT-only SOCs. We've got a couple of customers that have done that. Some of them have done it OT-only, and then they'll migrate that into their IT SOC at a later date. Some of them are going to keep them separate. But the vast majority of companies that we're working with are very large, and they're integrating an IT and OT SOC. This level 1, level 2 guys are already overwhelmed with alarms as it is. They don't need a bunch of new alarms that they find it difficult to triage. So that's certainly a problem. And the last thing is, those folks don't necessarily have the same skill sets. They don't have a bunch of OT knowledge, OT domain knowledge. Hopefully they're starting to get familiar with it, but they don't understand those control networks in a way that somebody that works at the plant or works in the operational environment on a daily basis does. So you've got to meet them where they're at and provide the kind of capability that even a lesser human who doesn't know those can do something with. So on the threat detection piece and detecting early and late, it's kind of funny. A lot of folks, we called the space initially. I never liked the title. I think I've had that discussion with Dale on one of the S4, I think it was the S4 Europe stage. When, in fact, some of the other vendors didn't like the title anyway, but they called it the anomaly detection space. That's only one of multiple engines, if you will, that we've implemented in our threat detection. So getting data passively or the other collection methods that we talked is just a part of that's how you do data collection. How you process that data and different what you do with it is different. So we've got multiple. So anomaly-based detection is certainly something we have. Signature-based detection for known threats is certainly something we have. We've got both security and operational behavioral analysis. It really puts our domain expertise into the product, and you can find something on find things on the security side like man-in-the-middle port scans and things like that. Or on the OT side, you can actually see OT process changes and things like that. Changes or anomalies that we might see in the network that could actually change the operational process. And then we've also provided custom rule-based capabilities. Lots of clients will use this for different things, but one of the use cases it would enable some of our clients when they be able to monitor out of bounds on certain settings, on certain set points. Is my pressure too high, too low? Is my turbine running too fast, too slow? Just monitor those ranges and alert on out of bounds kind of stuff. So in order to be a good tool to detect the kinds of modern threats that you're going to see from nation states, you end up having to have this level of threat detection capability. And we'll show 2 slides here. On the left side to you guys, you see kind of a traditional network scan, something that's going to happen early in the threat kill chain. The attacker's doing recon, early part of the playbook. They're running that part of the playbook and doing their recon. On the other side is, on the total, there's obviously potential alerts, all the way through this. On the other side, you've got something like what we called when we originally saw it was a configuration download. In fact, if you look at the fine print, it was a suspicious configuration download. And we went through in a lot of detail last year how we detected the Triton attack out of the box. It wasn't using signatures or anything. We detected it, tested it when we got the samples in the lab, and the first thing we did, other than starting to reverse engineer them, was to test them. The Schneider guys did the same thing. They had the tech as well. Stood up on the stage last year, and I think complimented us for being able to recognize that stuff out of the box. So pretty cool. That's a 0-day. So sophisticated part of the attack. Obviously, you'd like to find that the attack in the earlier stages of it so you can do something or stop it beforehand, but you really need a range of capabilities. All right, so let's talk about the second problem, this enabling alert triage. And really what you need there is a really accurate alert scoring. So as you see up there, we've got a score. If none of the SOC analysts believe in the score, if they don't know what makes up the score, so having a score is great, right? But if they don't believe in it, they don't know in it, they may ignore it, they may look at it. These again are guys typically in an IT/OT combined SOC that are doing a range of alerts, a whole bunch of them coming at them. You'd really like them to pay attention to high priority alerts coming from the OT environment, given the financial impact or safety impact that it can have in the environment, but you got to raise that up. So just having a score is the first piece. Being able to accurately do that, based on really rich data and correlating of events is important. So the next piece that you see there to the right is really just a list of the significant indicators that pop this score up. You see a tab there below. There's a whole set of indicators, and we do the scoring based on every little step. So this happened to be something that we hadn't seen before, which is the first indicator. It happened to be doing a configuration change, which is to a controller, which is a risky kind of event. Oh, and this was chained to a remote session. So it was not somebody in the plant doing it locally. It was coming in from a VPN session or something like that. So that's the second step. Do I have accurate and really contextually rich scoring that's also transparent? Do I know exactly what happened? It's got to be clear and transparent, because otherwise I can't take it from the alert and the triage. Okay, this is something I got to pay attention to. Now what the hell happened? How do I trace that back? Before having to go to the PCAPs and reconstruct it themselves, this is what we do. So in this case, we've really connected the dots for the analyst of these things that could have seemingly been, they could have been, would have been multiple, alerts that might not have raised above the threshold for them to take a look at, but chained together, connecting those dots, they became a severity, this one combined alert became a severity high thing. So a lot of folks are thinking about it from an IT perspective and doing that in your SIM and stuff, but if you can't marry those things, OT context, IT context in a blended attack scenario, you really can't, you don't have the information beyond triage for the folks to figure out really what's going on and then to take remedial steps. So this one's interesting. It's a new capability we announced, and we'd love to talk to you over at our Cabana session a little bit more. I'm going to try to, this is the hardest thing to explain and some of the most valuable thing that we've done. Very, very simply, we've created a capability built on top of our rich DPI to group the assets. I'll give you one, this isn't exactly the example here, but I'll give you a mind reference example. You might have a plant that's creating cough syrup. So the front end, line one, creates the syrup, mixes it, does what it needs to do, gets over to line two, and it takes the syrup and puts it in bottles and in packages and moves it along into the loading dock, loads it on trucks, etc. So it would be more rare that something on line one is talking across the zone to line two. So what we do is we've created this idea with these virtual zones. We put groupings of assets that are actually routinely talking. You might have a bunch of Rockwell assets, a SCADA system in one and on two. We group those assets that are talking to each other routinely, and that allows us to do a couple of really interesting things. First, as it applies to alerting, it allows us to really raise the contrast up on an alert or an anomaly that we see that's crossing a zone. So if you see some, an anomalous behavior going from zone one, maybe an HMI on the one side to the other line, that's something that you want a higher score on and you want to pay attention to, for example. The second thing that we do, and I'm going to defer this to kind of side discussions because I just don't have the time to cover it, is it can actually, it gives you a real map for doing actual real segmentation in your network. So it definitely provides a lot of value in for folks who want to actually take that next step. And whether there was a whole discussion this morning about whether we do segmentation up and down the Purdue chain, or we segment based on process flow, et cetera. Whatever model you use, this gives you a map of actually what's going on in your network, what's really communicating with what, so you can make those decisions whether you're implementing it with firewalls or VLANs or some other technology. So bottom line on this scenario is, if you miss certain pieces of the threat activity, that's bad. If it's invisible to you, if you can't see a Triton 0-day attack or the next one that comes along, that's problematic. Others would tell you, well, you're going to see the front end of the playbook and stuff, and that's true. You want to be able to watch for the whole kill chain of activity, but if you miss something, you want to be able to catch the more sophisticated part of the attack that may be replicating the particular OT protocol to actually do damage. So that's the 0 days. And the SOC analysts really need to be able to easily triage and quickly triage and then investigate this. And you have to have believability in your number. It can't be some BS, threat score that's not based on actual things that should make that up. So that it's not a compelling and transparent way to calculate that. So what's required? We think of a multimodal threat detection engine, something that isn't just doing anomaly detection but has a range of detection capabilities, is absolutely required. A really accurate scoring model that's really easily understood by the SOC team, and context-rich alerts, things that give the SOC analyst actionable information about exactly what happened and advice about how to carry forward.